everything you need to know about their data strategy and what they're building, or at least what they have built in the past, and kind of why they're doing it and what's driving it. And I think the reason a lot of these companies do that, because a lot of people might ask, why would companies, tell other companies how they're doing their work? I think one of the reasons that they do this is it's a great way to kind of advertise to engineers why they should come work for these companies, because they can kind of see what tools they could work with or what mentalities they can work with. Plus, it's just a great way, I think, of everyone to learn and try to implement their similar strategies into their own workforces. And it's really not that easy, I think, to just, read this article and then 100% layer it on top of whatever your company is doing. Again, companies like Airbnb or Spotify or Facebook have data engineering and data science teams that are 10x the size of most companies, and they spend a ton of money on data. So even though they're giving their blueprint away, they know that not every company is going to be able to layer it on top of what they're working with. It's not a one size fits all, but I think there's a lot of good learnings you can pick up from Airbnb's mentality of data and how they kind of looked at it. And you can kind of see how they went from kind of their old style of thinking of data and kind of how they grew and tried to mature into developing more of a centralized philosophy of data and how they should treat it. And I think that's what's really important here for you to learn, is that data engineering is not as simple as just piping data into some sort of end result, but it is really about creating some sort of like almost data product, not in terms of like a dashboard, but in terms of the data itself. And that's what I think we'll read here in this article. So let's dive into that real quick. So here we have Airbnb's article called Data Quality at Airbnb. This was part one, where they were talking about rebuilding at scale. And they're really going to focus a lot on kind of their old previous state in terms of their data infrastructure and kind of the current state they're trying to push into. And if you need social proof, this article has 1.7K claps on Medium. So that's a pretty decent article, especially in the terms of data engineering topics. It's sometimes hard to get just as much attention on like data quality and data engineering as it is on things like data science and machine learning. So the fact that it has 1.7K likes, I think, is pretty impressive. So let's dive into this article and see what Airbnb was dealing with in their previous state for their data infrastructure and kind of their current state and kind of what choices they made along the way. So I'm going to scroll down here and we're going to kind of see just a general intro and kind of a general background. So really early on, it's kind of more just very much general info on Airbnb, and we can probably skip a lot of this as it does bring up some things that might be interesting to some people, like Apache Airflow and Apache Superset. But I think what's going to be more interesting is looking at kind of their state of data in their previous data infrastructure. So in this case, their kind of move for improved data architecture and ownership was really pushed down from leadership. So you'll see that they kind of point that out here. Meanwhile, the requirement data also changed. For instance, leadership has set high expectations for data timeliness and quality and increased focus on cost and compliance. And this kind of pointed out that they early on need to kind of change their overall system, and they had a few key areas that they needed to invest in, which was ownership, data architecture, and governance. And they kind of discussed kind of why this was a problem. So for example, with ownership, you'll see that prior to having more of a like data engineering focused mindset, they had software engineers and data scientists being the primary owners of a lot of data pipelines. And this often wasn't clearly defined, which meant, when a pipeline breaks, when something is down, no one really knows who to go to or who to turn to in order to fix something. And, a lot of this kind of work becomes very tedious. And, you wake up in the morning and you realize you've got 2 hours of tasks just to fix a couple pipelines that have broken, and no one really wants to do that, especially if you've got a whole list of other things and meetings. And if you include that 2 hours plus all of your meetings, you might not have really any time extra to do actual work. And so you can see why people might not want to own this. Also, like most companies that have tons of different teams working on their data, there's not really a clear definition of your data architecture, which can often lead to things like, like they reference here, bloated data models, as well as kind of outside operational burdens in terms of small groups of engineers having to deal with a lot of just operational work and keeping these data pipelines running. And also this kind of, I think, somewhat, depending on how you look at it, bleeds into governance in terms of trying to have some sort of centralized governance strategy all over your data. And so those are the three areas they really wanted to focus on in 2019 to really improve their data and their data quality. So what you'll kind of see here is the natural flow of kind of developing any form of strategy or plan of attack. So, right, like up from high levels, from leadership, you had these three initiatives. They kind of defined it pretty ambiguously, right? Like they're like, okay, we want to improve architecture, governance, ownership, and now we need to define how we're going to do that, right? Like, so when you're developing strategy, you've got those three very high level concepts, and now let's define what those high level concepts mean. And they kind of put together these 5 goals off of those 3 initiatives, which is 1, ensure clear ownership for all important data sets. 2 is ensure all important data sets always have SLAs. 3, ensure pipelines are built with basically high quality, high standards, best practices. 4, make sure you've got data quality checks happening regularly, probably whenever that pipeline runs. And then 5, make sure that data is well documented and easy to find, because otherwise what ends up happening is people just end up rebuilding pipelines because they can't find data that exists. And now, if you're out there developing some form of data strategy, you can now take kind of these 5 high-level points and even maybe distill it further to have clear metrics on what success would be in terms of these goals. For example, you're going to need to define what clear ownership means. Does that mean you have some sort of tool where you can search up what pipelines exist and you can see who the owners are? Or is that just making sure that an owner exists in the code, right? Like with Airflow, you can attach an owner to it. So you'll need to spend a little bit of time thinking about exactly what these goals mean and what they mean for your company. All right, next they focus about organization, right? Like now that we kind of have an idea of what we want to do, we now need to start putting the pieces in the right places so that you can start doing the work correctly. Now, first thing that they noticed is, hey, they need to grow their data engineering community. That was number one. They're like, okay, we don't have a big enough or strong enough or tight enough data engineering community. They're probably not communicating enough. They need to be kind of sharing best practices more. Maybe we need to get in some more senior leadership, which is things that they noticed. So they started trying to improve those situations. For example, problems started early on in the whole process of maybe looking for data engineers because they realized they had data scientists and software engineers building a lot of their data pipelines, which means they had a whole myriad of kind of monikers and job descriptions probably that all kind of varied in what skill sets were required because no one had kind of a clear defined role of what is a data engineer at Airbnb, because it can be very different at different companies and they can have different roles. And here, if you've got software engineers building pipelines and data scientists building pipelines, you're going to get a whole host of different kind of end results on how these data pipelines look. Because here's the thing, data scientists and software engineers did not often have the same background. Software engineers are probably very heavy in object-oriented programming, whereas I think data scientists tend to be almost closer to functional programming if they do programming. They just tend to do things more in kind of a linear way where it's just, one step after another runs, versus I think software engineers try to think of the whole system and build some large complex system to run, a few data pipelines. So you end up with two very different results, which makes it really hard to maintain across your organization. If you move one software engineer to another place, or if you move one data scientist to another team and that pipeline that they're now maintaining is more software focused, where before they were maintaining pipelines that were a little more data science focused, it's going to be very difficult for anyone to kind of make that switch. And so now you've got another challenge. So you don't only have the challenge of hiring, but you have the challenge of training people across different teams because you've got different definitions of what a data pipeline even is. So you'll see that they had to reintroduce the concept of data engineer at Airbnb and really focus on making sure they brought in strong data engineering talent, very senior people who could really help define what data pipelines were at Airbnb. They also had an org structure that I think works really well for data-focused companies who have data coming in from all different angles. So instead of having one central team for data engineering or BI, they made sure that each pod, so something like finance or HR, all had their own data engineering teams, and then they could work in a decentralized manner without having to get too many requests, allowing the data engineers to be better aligned with whatever business role they were with. That way, if you're on the HR team, you're aligned with their goals, and the finance team, you're aligned with their goals, versus kind of being that guns for hire methodology where you just have one team that kind of goes out and maybe fixes the HR team, and then there's some giant finance project that you got to go out and fix, and then, maybe next month you fix some operational project, and it's kind of all hit and miss. You've got a lot of context switching, and instead now you can just focus and be like, okay, I'm on HR. These are the business needs that I need to kind of replicate in my data models, rather than having to constantly switch whatever data models you're thinking of. They also did something interesting that I think I really like, which is they ensured that their data teams were somewhere in the range of 3 or more people, and their focus here was on mentorship. So you can see that they're not just thinking about getting the work done, but they're thinking about how do we make sure that these people are supported, are having conversations with their peers, and also making sure they avoid too many staffing gaps, right? Like if you have one data engineer leave and your whole system falls apart, you're going to have a hard time. And I've seen that happen to a ton of companies where they've got 1 or 2 data engineers supporting the entire company, and both of the data engineers leave within 3 months, and suddenly now they have to call me and I have to look through their entire system and understand something that there's no one there to even describe. You're just kind of stuck looking through code and pilfering and looking through whatever documentation exists. And finally, the thing that I really liked here, which I think every company should do, is they created communities. Data engineering communities are great. Really, any form of community, whether it's around data science, software engineering, best practices at companies, are a great way of ensuring the fact that if there's questions that someone has, they can go ask it somewhere and not feel dumb. Stack Overflow is a great example for technology. Obviously, you will feel dumb if you ask a question, or at least ask the wrong question on Stack Overflow. But generally, if you're internally at a company, I think most people are interested in helping. So if you can put some sort of data engineering community group together, it's a great way of just growing out that knowledge, letting people find maybe questions that already exist that they have now. Maybe it's an error, maybe it's an architecture question. They have a data architects group, which is great because there's a lot of like little things when it comes to designing things like data models that are really complex and hard for one person to kind of maybe fully suss out. And you might need multiple people just to be like, oh, did you think about this angle? Oh, did you think about this angle? And so I think I really like the fact that they put together community groups where people could talk and discuss the problems that they're having and really try to learn from each other rather than, trying to sit in their own isolated shells to try to answer complex questions. And again, they've really started at the beginning. So hiring. They started with ground zero. Who are we hiring? They wanted to make sure again that they were hiring senior engineers, leaders, people that were going to like drive initiatives, right? Like if you've got a new initiative, you need people to drive those initiatives. So what better way to do that than make sure you've got good data engineers on your team ready to drive that initiative? So I think that's kind of a necessary thing, especially if you're going to take on a giant initiative. You want to make sure that you've got engineers that can drive it. It's kind of like, if you've got a lot of work that tends to be very migration focused or very, in some ways kind of tedious, but also necessary, maybe don't have your senior engineers solving all of those problems unless they can figure out a way to automate it. But there's probably something better for a junior engineer because it's a great way to kind of cut your teeth and really get good at whatever project you're doing, because you're going to do so many iterations of, migrating something that you're gonna be like, oh, now I see the difference between, Python 2, Python 3, or Oracle and SQL Server. Is it always fun? No, not really, but it's a great way to kind of see these differences. I learned a ton personally between like an Oracle and SQL Server migration of all these weird nuances between Oracle and SQL Server that I would have never thought existed. Things like how you order by with nulls is different depending on how your underlying database is set up, because you can actually set it so that nulls are on top or nulls are on bottom. I didn't know that was a thing when I first started doing databases, but I digress. Speaking of digressions, as a pretend YouTuber, I don't get sponsored by anybody right now, except for myself. But it seemed like all the real YouTubers were getting sponsored by a company called Magic Spoon. So I decided to go out and look for a company that was similar to Magic Spoon, which would be Three Wishes. Basically, just a cereal that is meant to taste like a lot of cereals we had as kids without like any of the sugar or gluten or any of the tasty things. So I'm going to give it a try, despite them not paying me anything. That's actually not terrible. You didn't come here to see me eat cereal, so let's talk more about data engineering. So you've hired a great team of data engineers, you've set up kind of their general org structure, and now you need to kind of give them the outline in terms of best practices. So where to even start? Obviously at the data model, e.g. how does your data actually get structured so that it can be used by data scientists, analysts, and whoever else needs their data. Initially, they had a concept called core data, which was kind of a star schema model, or at least based off of that. And initially it worked really well in 2014. Probably when the data that they were working with was a little simpler, maybe less complex in terms of design models, maybe didn't have as many kind of like add-ons or whatever, but apparently it did work very well initially. But as things kind of go on and as time progresses, data will become more complex, how it kind of comes in, how it's treated, what data is more transactional, what data is more slowly changing dimensions, all of these different things just start changing very rapidly. Especially in a company that's trying to be very data driven, it's very hard to have that same data model work forever. And they ran into a lot of issues by having centralized ownership, which they don't fully describe here, but there's a lot of different things that can happen when you're managing all of your data by one internal team. It's great when you're small. It's more difficult when you're large because if you want to do something, it's hard to do things fast. Now we're going to dive a little bit more into their data models best practices here in a second. But first, if you'd like to read a little bit more about an interesting platform, you should check out this article here. I don't actually know how to pronounce this. I'm assuming it's Minerva, but it's basically their kind of metrics platform, which they have another great article, honestly, which I could also talk about. Basically how they achieved kind of metric consistency at scale, which for anyone who's ever tried to get like the same metric across your company, you know how difficult that can be. So this is kind of their setup for that as well. They had clearly a ton of different giant data initiatives over the last maybe 4 or 5 years. This one's data quality, that one's metric consistency. So they're just trying to solve a lot of those problems that you'll run into as a data focused company, which is the more data focused you become, the more metric focused you become, the more people kind of end up bumping into each other. Everyone defines the same metric. The example I like giving is I once developed a metric that used kind of like multi-day trips as a numerator for kind of, what's the top value versus, over trips. And what's interesting there is like, now, do you define a multi-day trip as one that is across 24 hours? Or do you define it as one that's across over 2 days, right? Like if I start a trip at 11 p.m. at night and then end it at 7 a.m. in the morning, is that a multi-day trip? Even though you could have a 16-hour trip on one day, that isn't really the same. It's like, what does a multi-day trip mean? Are there certain minimums? Like, does it have to hit over 2 days plus be greater than X amount of hours? There's just these little things along when you're trying to define things that you need to be clear about that make metric consistency hard. But again, I'm digressing, so let's dive into the data model. So thanks to Minerva, they were able to do a lot more of a normalized data model because Minerva would take care of a lot of the heavy lifting in terms of joins. Also, they tried to, as much as they could, have tables that describe similar domains grouped in some single subject area, where those subject areas had a single owner, probably ownership group, I assume, not just a single person, but a team, so that they would own that, so that if there was a problem, people could go there directly and probably discuss, hey, we're seeing this issue, can you manage it? And personally, I've definitely found that this more normalized kind of data process, I think, works a little bit better because you can do a lot of the joins later on in the future rather than trying to maybe overly star schema something all the time. It really does depend company to company though. There are benefits to a lot of different models. As long as you're tracking the data in such a way that you can track historical information, I think that's usually the one thing you need to make sure you're tracking over time as a data engineering team. They also had a lot of other kind of questions here. For example, on Spark and Scala, what should they use? For example, they originally started with SQL, but they ran into issues with that. And so they ended up also going into things like Spark for other reasonings because they found that Spark had kind of a growing expertise internally. And this allowed them to invest their efforts into creating some sort of Spark wrapper to help simplify a lot of the reads and write patterns that needed to happen. They also did things like testing and data quality checks. They built a lot of new tooling around this. So this is something that I think that's important. It's not just doing data quality checks, but making sure you've got tools and systems that can automatically do that without you having to spend too much time, implementing it manually. I've definitely written articles about things like, making sure you've got basic level testing, like anomaly detection. That's usually something that's pretty quote unquote easy in terms of how to think about. I think it's harder to implement, but easy to at least understand, right? Like if you have more or less rows than normal, if you have rows that have, drastically new categories where you shouldn't have drastically new categories, or maybe if you're like a finance team and you're used to seeing like $1 million, but now you're seeing billions of dollars, that's another kind of anomaly detection that you might need to implement. And there's just different levels in terms of how you should implement data quality checks, but making sure you have those at almost every layer of where data is touched and transformed. Next, they also had things like operations. So putting in SLAs. I think SLAs are nothing new. I also think most of us dislike them because they tell you right here, configured with PagerDuty. None of us like being on call because of a data pipeline, but it is kind of part of the role in terms of data engineering. When things go down, sometimes we have to fix it. Hopefully, I think the one thing that's usually nice is some companies try to have people in multiple countries so that, you're not having to wake up at 7 a.m. Someone from the data operations team, maybe in Singapore or something behind you was able to fix a problem, or possibly in front of you, right? Like it's either they fixed it the day before, or maybe someone in New York is picking it up for you. Just somewhere other than, you having to deal with all of the problems all the time. That is why it's kind of great to have people like in New York, Singapore, Japan, and other kind of areas, because they can all kind of see when issues break in your data pipeline and then hopefully fix it, rather than, again, you having to wake up in the morning and finding that all your pipelines are broken. They also discuss their governance process in terms of, how they actually designed and built and pushed out data pipelines into the data warehouse. And this was kind of a great chance to do it, right? Like if you're going to rebuild your data warehouse, might as well take some time to rebuild your overall process in terms of how you push things out. And it's interesting here because they actually require some form of design doc, which sometimes is required in some companies, sometimes isn't. So that's kind of interesting there that they've actually even required something to the high level of a design doc. It's kind of great. It forces everyone to understand what's going on. It forces the business people to understand why they're building what they're building. Because oftentimes, I think as data engineers, we just get asked to build things without possibly knowing full business context. And sometimes, we have time to figure it out, but sometimes it just feels like people need things right away. And so we're kind of stuck juggling 30 projects at once and trying to figure out, which one of these projects is most important when everyone's telling you that their project is important. So the fact that they've got some sort of process here with some sort of review probably helps out the data engineers, probably protects them a little bit from getting too overwhelmed from everyone's needs. They also put up accountability, which is interesting. I think this is always a great way of kind of looking through, what's gone wrong. Bug reviews are always great. I think it's kind of a balance here, right? Like you don't want to feel like it's too much of someone's fault. Sometimes it's more of a systems fault. Like why was that person able to build or push out some code that was a certain way? I think it's always a great question also to ask. But on one side, there's also, hey, we had all these systems that should have checked it and you still put code out that wasn't good. Why was that? Is that something that was on you, or is that something that was on the system? And so having those bug reviews and things like SLA reviews is a great way to make sure that your overall system is working great, you've got a great data strategy, and that people just know that they need to make sure they're washing their systems. So I really enjoyed this article, and I'm just now realizing that it's not 1.7K claps, it's 1.5K claps. I'm clearly a little bit blind. Speaking of claps, just take a quick moment before I finish up this video just to smash that like button and subscribe. I really do appreciate it, and it really does, I think, help the YouTube algorithm understand that, this video is worth watching. And with that, again, I think this was a great video in terms of like seeing how a company that is very data focused, like Airbnb, sets up their data strategy. Again, this was just one component of their very complex data strategy. If you want to read more, check out their blog at medium.com on Airbnb-engineering. It's got so much interesting stuff in terms of how Airbnb is setting up their engineering team. It's got a lot of good learnings, a lot of best practices for data engineers, data scientists. If you want to see how these larger companies are doing it, just check it out. It's a great way to learn. I'm obviously on Medium, but I think this is where I spend a lot of my time, reading things like Netflix's blog, Pinterest's blog, Airbnb's. They're all great. All have a lot of interesting information. And if you like this type of video, comment below, let me know. Let me know if you want me maybe to do a little more of a deep dive, maybe into something more architecture-y. For example, I really like this article here, detecting image similarity in near real time using Apache Flink. I thought this was a great kind of end-to-end data flow example of how Pinterest was trying to detect image similarity. Obviously, there's some machine learning concepts in here as well, but there's also a lot of, I think, very similar things to data engineering, where they're talking about how they're actually processing this data, managing it, pushing it throughout this whole system in order to get it into these models. And I found it just kind of, I think, fascinating in terms of a great example of good system architecture. So let me know if that's something you'd be interested in or something similar. And with that, guys, I just want to say thank you so much for watching my video. I will see you guys next time. Peace out.